Bismillahirrahmanirrahim. Assalamu alaikum, dear students. It's your physics class today, and today we continue our next topic of unit number 3, that is tension in string. Now, what is tension? First of all, tension is the pulling force which is exerted by a stretched rope, string, cable, or cord on an object to which it's attached. It is called the tension force, or you can say that the force that is transmitted through a rope, string, or wire in any form when pulled by forces acting from opposite sides. These are called the tension force. This tension force, it is represented by capital T, and its unit is Newton. Now, what is tension? Tension is always a pull force. The direction of a tension force is always the direction in which one would pull the object with a string or rope. Suppose a person is holding an object of mass m. You can see in the slides. At rest, the body is at rest. With the help of a string, the object exerts a force on the hand through the string in the downward direction due to its weight. By Newton's third law, the force which is exerted by the string on the hand, it is called the tension in the string. So, the weight is moving downward and the tension is in upward. Now the tension is in upward direction, so the acceleration which is produced in the string, it is also in the upward direction. As the object is at rest, the magnitude of tension is equal to that of the weight of the object, as shown in the figure. Or we can also prove this, that F equals to tension minus weight, because tension is greater here. So we subtract the weight from the tension, and by getting the value of tension, we have minus W. So when the minus W will be shifted on the other side of the equality, it will be plus F plus W. Now the block is at rest. So F equals to MA according to the Newton's second law. Now if A equals to 0, because the block is at rest, so F equals to 0 and we get tension equals to weight. So we can prove by this equation then magnitude of the tension is always equal to that of the weight of the object. Now our next topic is about the Atwood's machine. Now what is Atwood's machine? Atwood's machine, when two objects of unequal mass are hung vertically over a frictionless pulley of negligible mass, the arrangement, it is called the Atwood's machine. Now you can see in this figure, we have two masses m1 and m2. Body A and body B. Body A represented by m1 and body B is represented by m2. Clear? Now these two bodies attached to an inextensible string passing through a frictionless pulley. The pulley is frictionless, there is no friction, and the string is inextensible string. Now in Atwood's machine, mass m1 moved downward. You can see in the figure, move downward under the action of gravity due to W1 and tension in the upward direction. Now two forces are acting on m1, W1 and T. Now if you see on the right side of the pulley, now here weight is greater than the tension, W1 is greater than T, and on the other side the tension is greater than weight, because the mass 2, it is moving in the upward direction because it is inextensible string, the same string is passes over the pulley. Now the acceleration is in upward direction, tension is also in the upward direction. Now here the tension is greater than weight. Now the mass m2 will move in upward in the direction of tension T. Now if we talk about the force on body A. Now on body A, two forces are acting on mass m1. First is its weight W1, that is equals to W equals to mg. So W1 equals to m1g, acting downward. And second is the tension of the string T, acting in upward direction. As m1 is moving downward, the net force acting on it is downward, due to which acceleration A is produced in it. Now it is all about the right hand side. Now, if we talk about the right hand side, the net force is equals to, because weight is greater here, so W1 minus T. According to the Newton's second law, we have F equals to ma and W equals to mg. So we get m1a equals to m1g minus T, and we have to find the value of tension. So T equals to, T move in the other direction and the m1a is move in opposite direction, so we get T equals to m1g minus m1a. It will be equation 1. Now if we talk about force on body B, now two forces are acting on mass m2, its weight w2 and which is equals to m2g acting downward, and second is the tension of the string T that is acting in upward direction. So m1 is moving upward, so the net force which is acting on the body, due to which acceleration is produced in it. So now here the net force is equal to tension minus W2. Now on the left hand side, tension is greater, so we subtract the weight from the tension. F equals to ma and W equals to mg. We get m2a equals to T minus m2g. By shifting the m2g on the other side, we get the value of tension, that is equals to T equals to m2a plus m2g. It is equation 2. Now since both equations 1 and 2 they are equal to tension, so therefore we can write m2a plus m2g equals to m1g minus m1a. Clear? Now rearranging these values, we move m1a on the opposite side and m2g also in the opposite side. So we get m1a will be plus and m2g will be minus. Taking common, a equals to m1 plus m2 equals to g m1 minus m2. Now we have to find the value of a, so this bracket m1 plus m2 is multiplying here, so it will be divided on both sides and we get a equals to g m1 minus m2 divided by m1 plus m2. Now the next topic is elevators and Atwood's machine. Now the construction. The supporting cable in elevator, you can see in the diagram that it is passes over a pulley. The cable that back down to a heavy movable counterweight. Gravitational forces acting downward on the counterweight create tension in a cable. The cable then exerts an upward force on the elevator cage. Most of the weight of the elevator and passengers is balanced by the counterweight. Only small additional forces from the elevator motors are needed to raise and lower the elevator and its counterweight. Although the elevator and counterweight move in different directions, they are connected by a cable. They accelerate at the same rate. Now to find the value of the tension, in equation 1 we get T equals to m1g minus m1a. Putting the value of a from the equation, we get T equals to m1g minus m1 and the value of a will be g m1 minus m2 divided by m1 plus m2. Now m1 is multiplying with the whole bracket and we get m1g minus m1g m1 minus m2 divided by m1 plus m2. Now m1g is taking as common and we get 1 minus m1 minus m2 divided by m1 plus m2. By taking LCM, we have m1 plus m2. Now, when we talk about the left hand side, we have the denominator, that is 1. So m1 plus m2 is multiplying by 1 and we get m1 plus m2. And on the right hand side, we have m1 plus m2 in the denominator. So it is cancelled and we get m1 minus m2 with the sign of minus. By simplifying these values, we get m1 plus m2 minus m1 minus m2. By simplifying it, we get m1 plus m2 minus m1 minus m2. m1 is cancelled with m1 and we get 2m2 divided by m1 plus m2. Now, by multiplying m1g with 2m2, we get 2m1 m2g divided by m1 plus m2. So, it is the simplified value of the tension. Now here we also have an assignment which is related to the topic of Atwood's machine, and this assignment is assignment number 3.8 in your book at page number 88. And the assignment is two bodies of mass 3.5 kg and 1.5 kg are tied to ends of a string which passes over a pulley. Find the acceleration of the bodies and the tension in a string. Now, for the solution, we have given data. We are given the two masses m1 3.5 kg and m2 1.5 kg. Now here they are passes through a pulley, so we have write the value of g, that is 9.8 meter per second square. And in the required data we have acceleration and tension. We have find the two values. Now we write the formula of the acceleration and the tension from the topic that is in Atwood's machine we have studied. Now in the solution, first we find the A and writing the value of A, we get m1 minus m2g divided by m1 plus m2. m1 equals to 3.5 kg. By putting their values, we get 3.5 kg minus 1.5 kg multiply by g, that is 9.8 meter per second square, divide by 3.5 kg plus 1.5 kg. When we subtract this 3.5 with 1.5, we get 2 kg, and multiplying by 9.8 we get and dividing by 5 we get 3.92 meter per second square, that is the value of acceleration. Now we find the value of tension and we have the formula 2m1 m2 g divided by m1 plus m2. By putting their values, we get 2 multiply 3.5 kg multiply 1.5 kg multiply g, that is 9.8 meter per second square, divide by 3.5 kg plus 1.5 kg. By multiplying these all values, we get 10.5, and multiplying with 9.8 and divide by 5, we get 20.58 Newton. Now, in this way, we can find the value of acceleration and tension. The acceleration equals to 3.92 meter per second square and the tension is 20.58 Newton. Hope that it is all clear to you. Inshallah, we will meet in the next lecture with the next topic. Till then, Allah Hafiz.